Hi, welcome back to our third video for 4.4 problems in two dimensions. In this example, we're going to use the sine law to solve a triangle. We're also going to check for the ambiguous case. So just to recap, the ambiguous case is always given when we have two sides in an uncontained angle. That's a triangle that looks something like this. We'd have this side, and we'd have that angle that's uncontained, meaning it's not between the two sides that are given. Okay, when we get this case, there may be two possible solutions. So two possible triangles may exist. So when we draw the first one, we'll then need to check and draw the second triangle. What's that second triangle? Well, it's usually this arm right here that's opposite to the angle that's given. This arm can usually swing out and then it intersects about right there. So this side length can be drawn somewhere along there too as well. Okay, let's read the question and see if we're given a side-side angle. So it says a lighthouse at point L is 10 kilometers from a yacht at point Y. So we're already given one length. And then it says it's also 8 kilometers from a sailboat at point B. That's our second length. From the yacht, so not from the lighthouse, but from the yacht, the lighthouse and sailboat are separated by an angle of 48. So that actually does sound a lot like side-side angle. Okay. So what does part A ask? It says, is it necessary to consider the ambiguous case? Explain. So yeah, it does actually mean we need to consider it. So we'll say here two sides and an uncontained angle are given. So we must consider the ambiguous case. All right. So when two sides in an uncontained angle are given, that's basically the side-side angle. Okay. All right, part B, sketch possible diagrams for the situation. Okay, so we were given the two distances from the lighthouse. So I'm going to start by writing the lighthouse up at the top. Okay, and it says a yacht. Yeah, it was 10 kilometers from a yacht. So I'm going to draw that out here. Okay, this would represent 10 kilometers. And then it says it's also 8 kilometers from a sailboat. Okay, and then there's an angle of 48 from the yacht. So from the yacht, if you look at the lighthouse and then the sailboat, there's an angle of separation of 48. So that just means there needs to be an angle of 48 here. Okay. So I'm going to draw the sailboat. It's 8 kilometers from the lighthouse. So I'm going to draw that. Draw that right over here. Okay, this is my first triangle, so I'm going to call B for boat. I'm going to call it B1 because it's for the first triangle. Here I have a distance of 8, and I'm just going to connect these there, and that's perfect. So notice this looks quite like 48. This side is 10. This one's a little shorter. It's 8. This is a good triangle that is drawn here. My second triangle. So we're not ever told what this angle is here. We're not even told how long this is. So I could actually draw this side here in a different location. So if I think of this as like a barn door and the hinge is right at point L, this can swing out and pivot and then it intersects right over here. So there should be an intersection point somewhere around here. That's my second triangle. That's what I'm going to draw off to the side. So what I'm going to do here is I'm going to kind of copy this out. Okay, so notice if this swings out, it doesn't really look like a good swing. If this swings out, it hits right here. So that's actually where my second possible position is for the boat. And these two lengths are equal. So kind of creates like an isosceles triangle. All right, so I don't want to populate this triangle too much. There's a lot of information that's written here, so I'm going to copy this out. I'm going to copy this, I'm going to paste it over here. Okay, and what I'm going to do is I'm going to erase a couple things. So I'm going to get rid of this stuff that I drew in here, because there's already enough information for us to solve. Get rid of that and that. Okay. So that's the first triangle. The second one, okay, it'll look like this. And I can erase all this stuff here. I'll leave that B2 in pink there. Go from there to there. Okay, and this is also 8 kilometers. So you can really clearly see how I drew the second triangle. Notice all the information is the same. 10, 10, 8, 8, 48, 48. Both these triangles work. Okay, the reason why we had 2 is because we were never ever told this angle, or this side length. Okay, just like in here, we don't know what this is, or this side length. So those are the 2 possibilities. Okay, part C, it's going to probably ask us to solve for something. So determine the distance from the yacht to the sailboat to the nearest tenth of a kilometer. If there are 2 answers, find both. If there are no answers, explain why. Okay, so there's our 2 triangles. And it looks like these triangles probably exist. We'll have to calculate some more information and see what happens. But we want to find the distance from the yacht to the sailboat. So I'm going to call that, I'm going to write it out in green. And I'll call it L1, okay, for both of these. So that one's L1. This one, it'll be called L2. So if I want to find L1, I'm pretty sure I can just use sine law, because I have a pair here. So like an angle and its opposite side, I have a pair there. And then if I get this angle here, I would then have a pair for these. So I'm going to need to find L eventually. So maybe we should find this angle first, and then we'll easily be able to get that one by doing 180 minus the other 2. Okay, so that sounds like a plan. We're gonna work with our acute triangle first. We should always do that, the one that has the smaller angle here. And then we'll worry about this one that has the obtuse angle after. Okay, so always start with your acute triangle. So we can say in triangle LYB1, we'll say use the sine law or apply the sine law to find angle B1. Okay. Once we get angle B1, we'll find angle L. When I'm using the sine law, I always write what I'm looking for first. I'm trying to find angle B1, so I'm going to start by writing sine B1 on the top over its opposite length. Its opposite length here is 10. That's going to equal sine of another angle in its opposite length, so another pair, sine 48 over 8. This should be real easy. We can just multiply both sides by 10 to cancel that out. Multiply this side by 10. So we have sine of B1 equal to 10 times sine of 48. Okay, don't multiply the 10 with the angle. That would be wrong. Okay, let's plug some of this in our calculators here. So let's do 10 times sine of 48. Divide all that by 8. Okay, we have 0.92. Okay, so sine of B1 equals 0.9289. Okay, to get B1 now, we're going to have to take the sine inverse of that. So B1 will equal the sine inverse of this. So what I can actually do is if I go up here I don't know if it'll work. Yeah, I'll just do it down here. I'm going to write sine inverse, and then I can write in my answer here, 0.92893. Okay, and 68.26. I'm actually just going to round down to keep things simple. I'm going to say approximately 68 degrees. Okay. The other way you can do this question is if you don't want to have to re-enter that tiny number, that 0.928, you can kind of keep everything in your calculator. So what I mean by that is you could get rid of this 0.928 and you can actually grab your expression from above and you could just write it in like that. Okay, and that's sometimes what I do just to become a little bit more accurate. Okay, so you actually take the sine inverse of all of this in your calculator. You put that in and it'll be really exact. And anyway, that's our answer here for B1. And now remember, now that we have B1, 68 degrees. Okay, we can now find this angle here. So this angle is just going to be 180 minus the other two. So minus 48 minus 68. That's minus 116. That's going to leave us with 64 degrees. So angle L is 64 degrees. All right, so now I can finally find L1 because we have the opposite pair. Okay, I'm just going to shrink some of what we just wrote out here. Okay, I'm going to say in triangle LYB1, we can apply sine law to find, and I called it L1. That's this length right here, L1. Okay, I always write what I'm looking for first. So I'm looking for L1. So I'm going to write L1 over sine of angle L. That's going to equal another pair that I know. And I like to stick with this pair. It's given in the question. So we'll do sine of 48 over 8. Or I'm sorry, 8 over sine of 48. You always make sure these go the same way. Side lengths on the top, angles on the bottom. Okay. Looking for L1. So let's plug in our angle L first. So we found angle L to be 64. So we're going to multiply both sides by sine of 64. That'll help us get L1 by itself on this side, and that means this side we're going to multiply that by sine of 64. Okay, so we actually have L1 equal to 8 times sine of 64. All of that is divided by sine of 48. Let's go ahead and do that here. 8 times sine of 64. Close that up, and we're going to divide all this by sine of 48. We got 9.67. So we'll say approximately 9.7. Okay, and I believe this is going to be kilometers, right? Because it has to do with the boat question. Yeah, we're working in kilometers. Okay, I'll write that up here, 9.7. So we actually just solved this whole triangle. We have everything in there. Okay, I know this has been a little bit of a long example. We now need to solve the second one for L2. This is actually going to go much faster. Okay, so remember earlier how I said when we draw that second triangle, imagine this is a barn door that swings and that this ends up going through like this. Well, when it does that, we can kind of use this as a cheat. So if B2 is here, what happens is these have the same side lengths because this is also 8. So this creates an isosceles triangle because these two sides are equal. what happens is these angles must be equal. So if these are both 68, well, that means I can use that to find this angle outside over here, which is actually this angle in here that we drew. So we're doing a shortcut. We're going to get all these angles real quickly, and then we'll be able to find whatever we're looking for. So I'm going to call this angle right here. Because this is a straight line and I know this angle, what's left over is going to be 180 minus 68. So it's going to be equal to 112 degrees. Okay, so I'm going to add that in right here. 112 degrees. So that's actually what you can do. So as soon as you solve this first triangle, this angle in here is always going to be 180 minus this one. Okay, so now we got 112. Let's go ahead and find the rest. That angle is going to be 180 minus the 48 minus the 112, and that gives us a total of 20. Yeah, because 48 and 112 make 60. Okay, or 160, yeah. All right, so we have all those angles now. I want to find this length, so I'm going to use this pair, and I'm going to use this. I could use this pair also given in the question. Okay. All right, so I can say in triangle LYB2, apply sine law to find L2. Write what I'm looking for first. L2 over its opposite angle, sine of 20, needs to be equal to another pair, and I can use this sine 48 and 8. So put the length on the top, 8 over sine of 48. Okay, multiply both sides by sine of 20. Okay, and we get L2 equals 8 sine 20 over sine of 48. This will be another approximation. 8 times sine of 20. Okay, then divide everything by sine of 48. And we get 3.7, we'll say, we'll round up, 3.7 kilometers. Okay, so there we have it. We've solved the two distances that were asked. So we can just say, therefore, the sailboat is either, the first distance we found was 9.7, so it's either 9.7 kilometers or 3.7 kilometers from the yacht. Okay. The last part of this question said, if there are no answers, explain why. So if we would have tried to solve this and maybe get errors when doing the sine law, it maybe might mean that there are no possible solutions. I just want to explain a little bit more about that too. So when we drew our first triangle, okay, I'm just going to erase some of this stuff here. Okay, the only way we could have no solutions is if this distance 8 can't reach this line. Okay, so we're told this is 10, and we're told there has to be an angle of 48 here, so that's given. And we're also told this line has to be 8 long. We're not told where. We don't know if it goes down straight, if it goes off at an angle this way or this way. We don't know. We just know it's 8. The only way there could be no triangle is if this 8 actually can't reach it and can't make this line here. Okay, meaning this angle is too big. If this angle was too large, this 8 could actually never reach and touch this line. Okay, how could we check for that? Well, real quickly, if you did a little bit of trig, a little bit of SOHCAHTOA, you could find the height of this triangle. Okay, what's the height of this? Well, if you look at this right angle triangle here, notice I draw a line going straight down, that makes 90. If you calculate the height, if this height is longer than this 8 here, you'll never be able to form a triangle. So that's something you can do to check. I'm just going to go ahead, I'm going to find h real quickly. So I can just use sine because h is opposite to the 48 over the hypotenuse. So I'm going to say sine 48 equals h over 10. Solving for h, we have 10 times sine 48. Okay, this number should be smaller than 8. Oops, not close. Okay, we got 7.43. So what I just found out, the height of this is 7.43, and this length we were given is 8. So this is long enough to reach and swing out and actually hit twice. Okay. There's one other thing that can happen too. This length could be really long, and maybe it's actually too long to create that second triangle. So what I mean by that is if this is really long, when we swing it out, it actually needs to swing past out somewhere over here. And so it only creates one possible triangle. You'll be able to see all this when you start doing your homework. But that's it for this example. I know it was a long example, so thank you for being patient. And I will see you guys in the next video.